Hello, my name is Caroline Payne, and I'm going to be talking about plate tectonics. I hope you guys enjoy my slide. So the first thing we're going to talk about are what are plate tectonics. The Oxford Dictionary describes plate tectonics as a theory explaining the structure of the Earth's crust and many associated phenomenons as resulting from the interaction of rigid lithospheric plates, which move slowly over the underlying mantle. And so what does that even mean? The Earth consists of multiple plates that are constantly shifting around. These plates are of massive proportion and typically move at a speed that is not noticeable from a simple observation. The average tectonic plate moves around 1 to 2 inches per year, which is almost unnoticeable, and that there are around 20 different plates. And how does that work exactly? So each continent has their own tectonic plate. This is the reason each continent appears to be able to fit together if picked up and moved. Over billions and billions of years, these plates have continued to move and shift apart. This causes all of the continents to continuously shift around and change over time. So next we're going to be talking about Pangea. About 350 million years ago, all of the tectonic plates were connected as one, and it was known as Pangea. And the ocean was known as Panthalasia. After about 175 million years ago, all of these plates began to shift apart to form their own individual continents that we now have today. So as you can see in this picture, the continents that we know of were once all together, which is pretty mind-blowing if you ask me. And so how do we even know this? So a German polar researcher named Alfred Wagner was the one that first proposed this idea. He believed that the Earth had slowly shifted apart over millions of years. To support his claim, he proved that the composition of the coasts of these continents were identical, as were many of the fossils found in the area. So I think that's pretty cool that a researcher was able to determine that some of the fossils were similar to other fossils across the world. And so what causes the plates to move? So the heat from the Earth's core, known as the thermal convection, causes the plates to move. The heat causes the magma in the Earth's core to rise and the cooler magma to sink. This pushes the plates around each other and causes them to move all around the Earth's surface. And so for an experiment to show how this works, I put an experiment that involves styrofoam cup. I didn't have any at my house, so I decided to show you guys with some cardboard pieces. So what I did is got a bowl of water, and I broke up some cardboard into 15 different pieces. And as you can see, when you move it around, the plates move as well. So this is a great example of how the plate tectonics work. So in summary, tectonic plates are directly responsible for the current development of all life on Earth. If it were not for the shifting of the plates, none of the life would have shifted to different geological locations to develop into what they are today. The ever-changing Earth continues to move a little more each day and will one day be completely unrecognizable compared to what we know today. So I think that's really cool, and I really wonder if there's a way if we can predict what Earth's going to look like in a million years. If there is, please let me know. Thank you. I hope you guys enjoyed my slide, and I can't wait to learn about y'all's.